Welcome to lesson 11, where we will be representing small numbers on the number line. We'll be visualizing small numbers on the number line using powers of 10. To be successful at this lesson, you'll be able to write a small number as a multiple of a power of 10. You'll be able to plot a multiple of a power of 10 on such a number line, and subdivide and label a number line between 0 and a power of 10 with a negative exponent into 10 equal intervals. We start with the warm-up, small numbers on a number line. Kieran drew the following number line, and Andre said that it doesn't look right to him. Either explain why Kieran is correct or explain how he can fix the number line. Pause the video here and try yourself before moving on. Now that you've had some time to work, let's talk about what we see here. So Kieran should actually change the -4s on the number line to a -6, and here's why. If we think about the last video, we're really dividing that 10 to the -5th into 10 equal parts. When you divide that into 10 equal parts, you end up with 10 to the -6. Therefore, each of those tick marks should be multiplied by 10 to the -6 instead of 10 to the -4. Keep this in mind as we move through the rest of the lesson. In activity 2, we'll be comparing small numbers on a number line. Here's some things to first recall. 10 to the -5th is 5 factors that are 1/10. And 10 to the -6 is 6 factors that are 1/10. So 10 to the -5th is 10 times larger than 10 to the -6. And you can kind of see how that relates to the number line that we just looked at. Representing numbers as a single digit times a power of 10 is useful for making rough estimations. So for example, 9 times 10 to the -12 is roughly 50 times as much as 2 times 10 to the -13, and here's why. We could think about this as 9 being close to 10. So you see here, when we're looking to see how many times larger it is, we're dividing to determine that value. And in this case, 10 divided by 2 is 5. And if we apply the exponent rules here, we would subtract them to give us 10 to the first power. And 5 times 10 to the first power is just 50. Okay, so using that to just kind of estimate and help us determine how many times larger it is. So in this activity, you're given a number line. You're going to start by labeling each tick mark on the number line and then plot the following 4 points onto that number line and then answer the remaining questions. Pause the video here to try on your own, and then we'll discuss together. Okay, now that you've had some time to work, this again looks very familiar to the warm-up. So we should have labeled the tick mark as such, where each of these are being multiplied by 10 to the -6. So make sure you do label all of those tick marks. And now we're going to go through and plot those 4 points. So notice our first one, A, 6 times 10 to the -6, can be plotted right here. But when we go to B, we see that B is written as times 10 to the -7. So we're going to want to rewrite that so we could then fit this onto the number line accordingly. So 6 times 10 to the -7, we're multiplying 6 by 1/10 7 times. That would be equivalent to saying 6/10 0.6 times 10 to the -6. So we could go ahead and plot that right there on the number line, kind of estimate where it falls. The next one, 29 times 10 to the -7th. Again, we need to rewrite that. So we would also say this is the same as saying 2.9 times 10 to the -6, which allows us to then plot that on the number line somewhere around here, probably a little bit closer to the right than what it's really at. But again, these are all estimates right now on the number line. And the last one is times 10 to the -5th. So we would want to rewrite that. So that would be 7 times 10 to the -6, which would fall right there on the number line. In comparing some of these for the third part, which is larger, 29 times 10 to the -7th or 6 times 10 to the -6, and estimate how many times larger. So just kind of comparing the ones that we rewrote, 2.9 times 10 to the -6 versus 6 times 10 to the -6, we know that the 6 times 10 to the -6 is larger. 2.9 is close to 3. So again, kind of using that estimation, we could then see that 6 times 10 to the negative 6 is about twice the size, right? So 3 times 2 would give us 6 if we estimated 2.9 to be 3. So we could say it's about double. In question 4, between the two that are given, which is larger, we're going to think about this a little bit differently. So we know 7 is about 2 times larger than 3, close to it, right? And then we also know that 10 to the negative 8th is 10 times larger than 10 to the negative 9. So we have 7 is 2 times larger than 3, and 10 to the negative 8 is 10 times larger than 10 to the negative 9. So ultimately, that 2 times larger and the 10 times larger would allow us to see that as being 20 times larger. Going into the next activity, atomic scale. Decimals can be thought of as a product of a number and 1/10. So for example, 3/10 is thought of as 3 times 1/10. 3/100 is thought of as 3 times 1/10 times 1/10. And this last one is 3 multiplied by a 10th 4 times. So just kind of keep that in mind. And we could see that written out here. Okay, so you're going to pause the video here. There's 3 questions that you're going to work on. In these 3 questions, you're expected to label each of the number lines and then rewrite the given expression to be able to place that point on the number line. Give that a try on your own, and then we'll come back and discuss. Okay, so this first one talks about the radius of an electron. It gives you its value in centimeters. First thing we need to do is we're going to rewrite this. So we can think of this as 3 times 10 to the negative 13. Now we have to think about how to represent this on the number line. So we know we have to place that 3 times 10 to the negative 13 somewhere on one of those tick marks, which means we really need to determine what that last value is and how we're breaking it apart into 10 parts. So that last value we would write as 10 to the negative 12th, because if we divide that into 10 parts, 10 to the negative 12th divided by 10 would actually give us 10 to the negative 13. So we would label our number line as such, which then allows us to place the point right here on that number line. Going into the second one, we look at the mass of a proton in grams. So let's first rewrite this. We're going to write this as 1.7 times 10 to the negative 24th. And remember, we're breaking this into 10 parts. So it wouldn't make sense to put it as 17. We would want to think about writing that as 1.7 so we could fit that on the number line. With that being said, that value at the end would be 10 to the negative 23rd. If we break that into 10 parts, then we would know that each of those values are being multiplied by 10 to the negative 24th, which allows us to then place that value somewhere a little bit more than halfway on that number line, close to there. In the last question, they give us point A on the zoomed in number line. It describes the wavelength of a certain X-ray in meters. So you could see that we're zoomed in between 7 times 10 to the negative 12th and 7 times 10 to the negative 12. The first part says to write the wavelength of the X-ray as a multiple of a power of 10. So we're looking at where point A is. And point A would be 6.1 times 10 to the negative 12, because as you zoom in on that part, you're breaking that apart into 10 more parts again. So we would have 6.1, 6.2, 6.3, etc., all the way up to 7 times 10 to the negative 12th. And so that's what that point A would be represented as. Part B says to then write that as a decimal, and this is what it would look like as a decimal. So again, you're multiplying 6.1 times 1 over 10 12 times, and that's how you're coming up with that decimal value. As we move to the right on the number line, what happens to the value of the numbers we encounter? They actually get larger. So just keep that in mind as we continue to kind of apply some of this in the upcoming videos that you'll see. Would 10 to the negative 5th appear to the left or to the right of 10 to the negative 4th on a number line? 10 to the negative 5th is smaller than 10 to the negative 4th, right? Think about how many times you're multiplying by a tenth by. So it would be to the left. Describe how to convert a number, such as the following, into a multiple of a power of 10. So we could think about 278 times the following decimal. We can also think about it as 278 times the following fraction. We can also think of it as 278 times a power of 10, so 10 to the negative 6, right? How does zooming in on the number line help express numbers between the tick marks? It allows you to subdivide the distance between two tick marks into 10 equal intervals, which allows you to describe a number to an additional decimal place. You can read through the lesson summary if you choose. Otherwise, you are successful at this video if you could write a small number as a multiple of a power of 10. If you could plot a multiple of a power of 10 on such a number line, and you can subdivide and label a number line between 0 and a power of 10 with a negative exponent into 10 equal intervals, which we did all of those in this video. So that is how you know you're successful.